there are several adjustments that you can apply to your images after they've been acquired, and some software tools and options that can affect your data when they're used. These include rotation, flipping, noise reduction, brightness and contrast changes, quantification tools, background subtraction, and export options. We'll discuss these factors in this lesson. Sometimes when you've acquired your images, you may need to rotate them. Maybe you placed your blot on the imager at a slight angle, or maybe in the wrong orientation, or perhaps you just want to make sure that your images are perfectly straight for the nicest possible presentation. It's important to realize that some types of image rotations are always acceptable and have no impact on the quantitative results, whereas others can actually affect the data that you get when you quantify. For example, if you rotate the image through 90-degree increments or flip the image from one orientation to the other, it will not affect your data. However, if you rotate the image through any other increment, it will. This is because your images are made up of pixels and pixels are square. So if you rotate the image through 90 degrees or flip it, the individual pixels' signal values do not change, only their relative locations on the image. So when you quantify the resulting image, you are still quantifying the same signal values, just in a different orientation. However, if you rotate the image through just a few degrees, your software will then have to recalculate every pixel's signal value to create a new image. This means that if you quantify the resulting image, you are no longer quantifying the raw data. It has been modified by the software. The results would then be somewhat different to what you would have seen had you quantified the original image. Ultimately, it's recommended to only quantify the original image or one where only 90-degree rotations or orientation flips have been applied. Images that have been rotated through anything other than 90-degree increments should not be used for quantification and should be used for presentation purposes only. But if you're going to do this, make sure to make it clear that the image has been free-rotated. Another modification that could be applied by the software is the use of a noise reduction tool. This is a special software tool that can be used to improve the appearance of an image by cleaning up speckles of dust or dirt, or perhaps electronic noise that's been introduced by the camera chip or the detector. There are many different methods and algorithms that might be used for noise reduction, but all of them will modify the data that will be quantified from the image, and they will change the way that the image will be visually interpreted. The software has no way of telling which pixels are noise and which pixels are genuine signal, and so some signals will be lost or changed by the use of the noise reduction tool. For this reason, it's never recommended to apply noise reduction to your images. Most journals currently don't accept noise-reduced images, even for presentation purposes only. Some types of software can modify the images in other ways. Some programs have quantification tools that work based on the actual appearance of the image, rather than quantifying the signal values directly from the detector. This is because they rely on a technique called densitometry, which is a measurement of how bright or dark a given band appears on the computer screen. If you were to apply a change to the brightness or contrast of your image in these types of software, and then quantify a band, the resulting value would be different to what you would have seen in the original image. Sometimes, the resulting change in the measured signal values from band to band is not even proportional to the change in brightness or contrast. This means that changes in brightness or contrast can change not only the signal values for each of the bands, but the trends between them as well, and as you can imagine, this can dramatically affect your data. Ideally, you should use a software package that doesn't rely on simple densitometry, but instead on direct measurements of the signal from the raw acquisition, such as Empiria Studio software. In this program, changing the brightness and contrast has no effect on band quantification, meaning that you can optimize image appearance without affecting the quantitative data. Some software packages also require you to draw the same size quantification boxes around every band. Now this is a problem because, as we all know, Western blot bands tend to be different sizes, so one size fits all doesn't really fit at all. Ideally, you should always choose a software that allows box sizes to be different and appropriate for each band, and which takes those box sizes into account when producing final signal values. Empiria Studio software works in this way. Another aspect of signal quantification that can vary from program to program is background subtraction. Although there are many different ways in which background subtraction can be applied during signal quantification, you should always consult your software's manual or help documents for detailed information on how each option works. The effectiveness and accuracy of these options varies, but ideally you'll be able to use one that minimizes or even eliminates user subjectivity and provides the most comprehensive analysis of background for each individual band, but all the while not affecting the appearance of the image itself. It's important that these calculations also take into account the fact that background is not even all the way across the membrane. A local background calculation takes a small reference area around each one of the bands and assigns a unique background value to each band. This will provide more accurate results than assigning one random area of the membrane as a single background reference for all of the bands. However, user subjectivity can still be an issue with this approach. Adaptive background subtraction in Empiria Studio software fulfills all of the required criteria, but you should consult the documentation for your particular software for further insight into the options available. Remember that your image can also be affected by the way that you export it. You need to check whether your software allows you to export a raw unmodified image, a compressed version of that image, or both. If you intend on carrying out further analysis of your image or submitting it to a reviewer, you should always export the raw image in its original uncompressed format. You will need to check the instructions for your imaging system or software for how to do this. Other options for image export will compress the image, usually to reduce the file size or to improve cross-compatibility with other software programs. Remember that image compression techniques are typically lossy, which means that some data will be lost when you do this. Usually this results in a dramatic decrease in the dynamic range of the image, but it can also affect the appearance of the image as well, by decreasing the resolution or fidelity of the image or introducing image artifacts. You should only ever use the resulting images for presentation purposes, as the data loss will definitely affect your quantification. We've now covered several different types of possible image manipulations or adjustments. Our next lesson will be a summary of recommendations so that you will know the best way to proceed with your images.